Very good. Watch what happened to the bases. There's no other technique out there. All right? If you have any, I will show you just right now. Look what happened between them. Look the one I did before that. You want to compare them. It's this side I work on. But this time I work on this side. Check it out. Mathematics is not a hard thing. Once you see it, you can do it. Good. So let's move on to another technique. Now, student, follow up here. We're still solving for x, and then I have a base 2. This is the type of 3. Example 3, which is equal to 7, for example. You see that? Now look at that. Look at that. This is up. Look at 7. I cannot break 7 in the base of 2. That's impossible. Follow? Because 7, if you look at it, is a prime number. You cannot break that. So the problem is how you solve for x that is an exponent. It's not down. It's up. How you bring it down before you solve it. That is the problem. Here I cannot break it. Look at this example. It's different from the two first one. Look at it. There's no definition here. It's your observation. Now I cannot solve it unless this x comes down. There's no simple base in between them. I will bring in what I call then my logs. I will bring logarithm in. I will say ln 2x equals ln of 7. This is a number. ln 7 I know. You see? I bring an operator. When they have the same like that, I bring that. You follow? Now, remember the rule that I give you last time on the law? It says ln of x to the power, let's say, to the power y is equal to what? Is equal to y is equal to y ln of x. Remember the law that I gave you last time? That if you see something such, that's what it is. So look at it here. So this becomes x ln of 2, which is equal to ln of 7. These are numbers. So automatically you divide both sides by, so x here is equal to ln 7 over ln of 2. That is your answer. These, you can find them on your machine and you can get an answer. But if you can get right here, believe me, I get you your credit. Does that make sense? I want you to look at it. Compare the third example to the two first. Take your time. If you punch that in your machine, it's going to be something close to this 2.806. It's an approximation. Okay? But remember, I don't care so much about that. This is it. The one I put in the back, if that's true, I'm done. What I want you to understand is not what I could do to bring that x down. I cannot solve as long as x is up. To bring x down, I got to remember the law of cosine or the law of logarithm. Hear me, students? All right. Simple. If you don't want this, you can do the same thing. You can do the same thing. You can take this. You can bring also log 2x equals log 7. Remember, when I don't put any base, it's automatically what? The common base which is 10, is in your machine too. So if you do that, no, I'm sorry. It's x base 2. So automatically, x is exactly equal to it. Log base 7 over log of 2. The base is automatically 10 here. So either you have this or you have that. You still have the same answer. Those two answers will give you the same thing when you punch in your machine. If you use this, you use the base 10. want to use this on your machine, you will take this one. That's the ln, but here as the second function, you put e to the x. You choose that, but you're still going to get the same answer, either one you choose. Am I making myself clear? It's very good. But I'm not worrying so much about this numerical answer if you can give me the literal one. All right? The literal one is enough for me. Either you have this or that, I'm okay. All right? Very good. Very good. If you have a professor that wants the actual number, if you use this, you use then the log base 10, the common base. Now, if you use this one here, then you use the ln, the natural base. Does that make sense? All right. Can someone tell me yes or no before I move out of here? Okay, I'll take your word for it. And everyone's seen your yes. All right. Miss Boy, you recording this, right? Come on. All right, thank you. So let's do another example. Remember, what you're observing here, 7 couldn't break. You couldn't break 7 in the base 2. You could not. That's why you have to bring log in. So the operator logs come on both sides to solve the problem.